do it. It's go time.
Welcome to Go Time, your source for wide-ranging discussions from all around the Go community. If you like this show, you'll love the Changelog. It's news on Mondays, deep technical interviews on Wednesdays, and on Fridays, an awesome talk show for your weekend enjoyment. Find us by searching for the Changelog wherever you listen to podcasts. Big thanks to our partners at Fly.io. Launch your app in 5 minutes or less all around the world. Learn how at Fly.io. Okay, here we go.
What's up, nerds? I'm here with Kurt Mackey, co-founder and CEO of Fly. You know we love Fly. So, Kurt, I want to talk to you about the magic of the cloud. You have thoughts on this, right?
Right. I think it's valuable to understand the magic behind a cloud because you can build better features for users, basically, if you understand that. You can do a lot of stuff, particularly now that people are doing LLM stuff, but you can do a lot of stuff if you get that and can be creative with it.
So when you say clouds aren't magic because you're building a public cloud for developers and you go on to explain exactly how it works, what does that mean to you?
In some ways, it means these all came from somewhere. Like there was a simpler time before clouds where we'd get a server at Rack Shack and we'd SSH it or telnet into it even and put files somewhere and run the web servers ourselves to serve them up to users. Clouds are not magic on top of that. They're just more complicated ways of doing those same things in a way that meets the needs of a lot of people instead of just one. One of the things I think that people miss out on, and a lot of this is actually because AWS and GCP have created such big black box abstractions. Like Lambda is really black boxy. You can't like pick apart Lambda and see how it works from the outside. You have to sort of just use what's there. But the reality is like Lambda is not all that complicated. It's just a modern way to launch little VMs and serve some requests from them and let them like kind of pause and resume and free up like physical compute time. The interesting thing about understanding how clouds work is it lets you build kind of features for your users you never would expect it. And our canonical version of this for us is that like when we looked at how we wanted to isolate user code, we decided to just expose this machines concept, which is a much lower level abstraction than Lambda that you could use to build Lambda on top of. And what machines are is just these VMs that are designed to start really fast or designed to stop and restart really fast or designed to suspend sort of like your laptop does when it closes and resume really fast when you tell them to. And what we found is that giving people those primitives actually, there's like new apps being built that couldn't be built before, specifically because we went so low level and made such a minimal abstraction on top of generally like Linux kernel features. A lot of our platform is actually just exposing a nice UX around Linux kernel features, which I think is kind of interesting. But like you still need to understand what they're doing to get the most use out of them.
Very cool. Okay, so experience the magic of Fly and get told the secrets of Fly because that's what they want you to do. They want to share all the secrets behind the magic of the Fly cloud, the cloud for productive developers, the cloud for developers who ship. Learn more and get started for free at fly.io. Again, fly.io.
Well, hello. Welcome, listener. I'm Johnny Borsico. Welcome to another episode of Go Time. Today, I have a very special guest, someone who decided to go on a very interesting journey, one that I personally would find very daunting. This individual decided to write themselves a shell. You heard that right. You know, like the ZSH or Bash, or like he decided to write himself a shell, and he did it in Go. Welcome, Qi Xiao.
Hello.
Where do we start? Like, of all the side projects you could have come up with, why a shell?
Right. So I started Elvish about 11 years ago, I think. And at that time, the alternatives you have picking the shell is like traditionally there's Bash, there's always Bash, and there's ZSH. And there was Fish was along for quite a while. I just felt all those shells were a little bit limiting, and it is something that people use all the time. Mm-hmm. And the shell is this interesting thing where it's both a programming language, but it is also kind of a UI people use to access their operating system. Right? It's why it's called a shell as opposed to like a kernel of a system. And I think implementing a programming language is pretty fun. And also just like doing UI stuff is also pretty fun. And so I think a shell would make a good, interesting project.
And you've been working on Elvish, right? That's what you named your shell, your implementation. You've been working on that for how long?
11 years.
11 years. Wow. Now, is that because that's it's a kind of an on and off kind of thing, and it's just obviously it's not your primary way you make a living, so that's kind of been. It's not because it took 11 years to get a working shell. It's just more like you've been working on it for that long, right?
Yeah, it's an on and off thing. I mean, I started the project when I was still in uni, so I had a bit more spare time. But as I got like a full-time job, there's a slightly less going on. And I've not been working recently, so I spent more time recently on Elvish. But if I go back to full-time employment, I'll probably spend a little bit less time on it.
Right.
So a lot of the kind of the developments that get you a basic shell kind of happened in the first year or so. So I started kind of daily driving Elvish just about half a year into developing it. I was switching between Zesh and Fish at that time, but after working on Elvish for about half a year, I decided it has enough features for I to use it as kind of my default terminal shell.
So Elvish is your default right now. Pretty much everything you do that you need to do in a shell is you basically you consume your own dog food, as they say.
Yeah.
I see. So we've sort of touched on sort of what a shell sort of is. It's both a programming language and sort of an environment for executing or for sort of stringing together. Most folks listening to the show will be familiar with the concept of a shell. But like, what ultimately is a shell? It's just an execution environment, or how would you describe that to somebody who's not sort of in the know?
Yeah, it is a very good question, actually. So I think from a purely technical perspective, the way I would describe a shell is that it's basically just another terminal application. So it's on the same level as like LS or Vim, except that like Vim is like obviously is much more interactive than LS, right? But they pretty much function at the same level. Like they run the terminal, they write some outputs, and they are capable of taking. Oh well, LS is not capable of taking inputs, but think about CAT; it's capable of taking inputs. And there's a lot of obscure kind of terminal API stuff going on, but that's not kind of essential difference between these programs. And on a technical level, we can think of the shell just like another terminal application, except that the thing you do with the shell is mostly just launching other applications, right? But on a technical level, they are very similar. But that's kind of just a purely technical answer. But people often confuse shell with terminal, which I think is not because people are not. I think like on the one level, some people are just not familiar with how like the way things are done kind of in the Unix world. But on the other level, I think there is a bit of kind of truth to that, right? Like when people think about the shell and the terminal, people think of it as kind of this, like not exactly the same, but kind of part of your kind of text-based working environment. So in that sense, on a more conceptual level, you can say a shell is actually slightly different from all the other terminal applications in that it's actually more in your environment instead of like yet another application. I think that's actually a very interesting phenomenon. And it's almost a historical like incident that Unix decides to do things this way. Like you have the terminal and you have the shell. Those are two different separate programs. But it's easy to imagine a world where things don't work that way. But in the Unix world that we live in, a shell is technically just another terminal application. But it's a slightly special one in that it's probably the first terminal application that's launched by your terminal, right?
Right, exactly. As you were describing it, I kept thinking that, okay, well, every time I launch a program, a terminal program, whether it's I happen to be using Mac OS, so there's the native sort of terminal app, right, that you have that comes with your operating system, and then personally I use iTerm, which is another popular one, but I'm sure there are others out there. But those things are programs, so by default they launch a shell, right? It could be Bash, right? By default, that's what the terminal app does. But when I launch iTerm, the program, it launches a shell, and my shell, right? I basically didn't use. I wanted to not stick with the default, which was Bash. I wanted to use ZSH instead. So I installed ZSH and I made that my default. So it's almost like the terminal. Could I think of it as sort of the back end, and the shell is the front end that I use to interact with the back end?
Yeah, I think that's a good way to think about it. You can almost think of the terminal as a kind of graphics runtime, except that most of them only support graphics in the sense of like just text.
Right.
And another way to think about it is maybe you can think of the terminal as a browser, and you can think of Shell, Vim, and LLs, CAD as just like websites. That's another way of looking at it. Except that the terminal does much less than the browser, because part of its functionality is kind of delegated to those applications. Like some terminals they don't do tab management, but you can use Tmux for that, right? And Tmux can run other programs inside them. So it's like a browser where you can nest tiny other browsers inside those browsers.
Yeah, it's. I remember there was a time when I used to use Windows, many moons ago, and I would see, like in the movies, like some movies did actually, an okay job of representing what, the quote unquote hacker culture was, if anybody who's ever seen the old school movie, Hackers with Angelina Jolie and some of the other famous people will remember, like they were actually using a terminal, they were issuing commands. I'm like, oh, this is so cool. Like, how do I become one of those people? Right. So, but I was on Windows and I'm like, you launched a command program on Windows. It's like, it's just not as cool. So I started trying to use Cygwin back then, which was, there was no PowerShell back in those days. And like I kept trying to sort of embrace the shell life, if you will. Eventually, I tried Linux. Back then it was still rough, on the desktop. Every year we're like, this is the year of Linux on the desktop. Never quite made it. I'm not sure if things have changed since then, but eventually I was like, okay, I need sort of my operating system to get out of my way so I can get things done, but I also need the power of a shell. So I settled on Mac OS and that whole, and then basically I started embracing the shell more because ultimately, and we'll get into what some of the behaving capabilities of a shell are and what Elvish does, differently. But I started noticing that, or rather, when one is sort of learning, right, to use a shell, you go through this sort of metamorphosis of things you used to sort of point and click and to get things done, to move around your machine, launching Finder windows and blah, 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 trying to navigate your system. You start finding that you can sort of type your way through that and do pretty much virtually all of these things, but using text input instead. You go through this metamorphosis. It's like, wow, this is really cool, right? Like a layperson would be like, what are you doing? Like, this is like crazy. Why would you want to use your computer that way? But no, for a certain kind of individual, that is sort of a dream, right?
Yeah. I think a lot of us went through that journey, right? I think when I first got into Linux, I was also very attracted by like people doing cool stuff in this black window. like one example I always tell people about is FFmpeg, because when people want to do like not exactly like video editing, but simple-ish, but not that simple video processing stuff. Like I just want the first 10 minutes of this video, right? Or like I want to just extract the audio out of this video. If you are like in the GUI world, because there's just so many different things you can think about doing video processing. Either you try to find a very, very specific kind of GUI app that's just like a audio extractor, and then you give it you feed it a video file and it spits out an audio file, like the very, very specialized GUI app. Or you go kind of go full in and install a video editing app that's like 100 gigabytes these days. Right. And then you click through its menus and do this one thing that you want. But when you come to kind of the terminal world, like it's just Google for FFmpeg command. It's probably like a single line of command. And you can do so many different things because the terminal interface is such a kind of a thin layer of abstraction over kind of the underlying code, right? Like I suspect that the CLI of FFmpeg is probably just a small part of the entire code base. But if you do like a GUI application, if you do a GUI equivalent of FFmpeg, most of it is going to be like how do I organize the menus, like how to place each button, like things. You have to think a lot about that kind of things. But in the terminal, because it's such a thin layer of abstraction, you suddenly get access to much more easily as well.
What's up, friends? I'm here in the breaks with David Xu, founder and CEO of Retool. So David, Retool has definitely cornered the market on internal tool software development. But zoom out for me. What's the big idea? Why did you start Retool? What is the big idea with internal software?
Yeah, so Retool started at this point 7 years ago. And when we started Retool, the core idea was that internal software is a giant category that no one really thinks about. And what's surprising to most people is that internal software represents something like 50 to 60% of all the code written in the world, which might sound pretty surprising. But if you think about it, most of us in Silicon Valley, we work at software companies, whether it's like a Airbnb, a Google, a Meta. These are all companies that are software companies selling software. And so most engineers in these companies are working on external-facing software. But if you think about most software engineers in the world actually don't work at these software companies. There's not that many of them. There's maybe 10, 20 of them, big ones at least. Most of the companies in the world are actually non-software companies. So if you think about a company like an LVMH, for example, like a Coca-Cola, for example, or like a Zara. Zara is not selling any software, but they actually have a lot of software engineers, actually. And all their software engineers, all they do day in and day out is basically build internal software. So that's, I think, one reason we started Retool. The second reason we started Retool is if you look at all this internal software that people are building, it is remarkably similar. So if you take a look at, like a Zara, for example, versus a Coca-Cola, two very different companies, obviously. One a clothing company, one a beverage company. But if you actually look at the software they're building internally to go run their operations, it is remarkably similar. It's basically forms, buttons, tables, all these sort of pretty common building blocks, basically, that come together in different ways. But then if you think about, not just the UI, but also what's the logic behind a lot of this stuff, they're pretty much just hitting API endpoints, hitting databases. You care about authentication, you care about authorization. These are sort of a lot of common building blocks, if you will, to internal tools. And so for us, the insight was, wow, internal software is a ginormous category, and it's all so similar, and developers hate building it. And so could we create a sort of higher level framework, if you will, for building all this software? And that would be really cool.
That would be really cool. Okay. So listeners, Retool is built for everyone, built for enterprise, built for scale, built for developers, and that's you. And if you found yourself nodding your head to what David was saying, then check out Retool at retool.com/changelog. It's the fastest way to build internal software. Do yourself a favor, get a demo or start for free today. Again, retool.com/changelog.
So why Go? Why pick Go for such a task?
Right. So think about yourself in like 11 years ago. And it's a little bit surprising but the kind of programming language landscape is actually a little bit different from today. So when I first started working on Elvish, Go actually just came out. It was not literally Go 1.0, but it was 1.1. So it came out like half a year before that. And when I was thinking about if I want to write a new shell, what are my choices? At that time, the pretty much the choices are C or C++, Java, or like a more high-level dynamic language like Python, right? And Go at that time was this very kind of modern kid that's much less verbose than Java, that's much more expressive than C and C++. It's also much faster than like Python or Ruby. So it was pretty much a no-brainer at that point because Go was this super modern language 11 years ago. Mm-hmm. If people make a choice, if people try to decide to write a new shell today and decide which language they should do it in, the choice will be slightly tougher because today we have Rust. Like Rust didn't actually came out 11 years ago, but I'm sure there's a pre 1.0 version in development, but it wasn't really known at that time. There's Rust, there's Zig, and there's a bunch of other kind of modern and compiled languages. But I would still do it in Go because of things we'll probably discuss later.
Right. So that's interesting. These days, you're right. Most people would think of writing such a project probably using Rust or Zig.
Yeah.
And not the one I'm thinking about. It'll come to me later. But I think Go used to be labeled as sort of the systems language as well. I remember the early days of Go. People used to refer to it. I mean, even I think the Go doc, right, used to refer to Go as a systems programming language. But I think, over time it found this niche sort of. I mean, you can still do system programming stuff, but I think most people these days would pick sort of a lower level language and sort of Go rules sort of the cloud stuff, right? Like that's Go won that battle, right? But yeah, it's like watching sort of the programming language itself sort of find its niche, right, within the tech ecosystem has been an interesting journey sort of to watch go through.
Yeah, I think kind of on a side note, I think the debate around system language is actually quite interesting because I think the original creators of Go, when they say system programming language, they're probably more thinking about distributed systems instead of operating systems. And I think today the niche of Go does not contradict that, right? Because all the cloud stuff what you're doing is fancy distributed systems. But yes, the niche of something more close to the operating system is probably more occupied by like Rust and Zig these days.
Mm-hmm.
But you can still do a lot of like not real-time low-level stuff, but fairly low-level stuff with Go. Like Go has very complete binding for all the system calls on Linux, BSDs, and Windows. So you can do pretty low-level stuff as long as it's not like literally like real-time. That if you can live with a little bit of garbage collection latency, then you're probably fine.
So I'm curious if obviously being able to sort of distribute Elvish on all the major operating systems as you're able to right now, I'm definitely thinking that Go definitely plays a role in that, being able to have a single binary for every single platform, and writing sort of building those features. Did you have to sort of do different things for different targeted OSs and platforms in your code?
Yes, but not as much as you would think. So one thing I did differently for different platforms is how you read keyboard events from terminals, because Windows actually has a different API for reading keyboard inputs that actually gives you. So if you are curious about the subject, you can just look up like terminal escape sequence, something some keywords like that. So the way keyboard input works in the terminal is much less than straightforward. If you type a simple letter, like if you type A or B, that's what the program sees. But if you use a function key like F1, F2, like home, end, or God forbid you use a modifier with your function key, there are 10 different encoding schemes that that different terminal emulators use to represent those keys. So you have to, as a shell, you have to like parse all those escape sequences and back into keyboard, into like modifiers and like function keys. But Windows actually has a much more sensible API that just gives you like, this is the function key, this is the modifier key. So I used that on Windows. But Windows now also supports kind of it's called VT100 style escape sequences. Like Windows also supports that terrible way of encoding keys. So it's technically no longer needed, but I like the fact that Windows actually has a much cleaner API for that. So this is one place where it's different code paths on different operating systems. And aside from that, there's actually surprisingly little platform-dependent code. So one thing you might think that would be different is how to launch external programs. But Go actually has a very complete abstraction for that in the os/exec package. So it gives you pretty much everything you need in a shell to launch external programs. And if you think about how shells launch external programs, it's some of it can be pretty fine-grained, right? Like you need to control the environment of the program. You need to control where the output goes. Like if it's in a pipeline, the output goes to a pipe instead of to the terminal. Like it probably goes to a file, like things like that. But Go actually gives you everything in a portable way in os/exec. So I didn't actually have to write. There's a tiny bit of platform dependent code there because os.exec, the argument it takes contains this field. I don't remember the exact name of it, but this field that basically says system dependent metadata. And that is the only thing that I need to make it kind of per platform. But other than that, it's quite portable. And obviously, like there are some things that are Unix specific that has to be platform dependent. Unix has umasks, which is a bit field that's applied when you create a new file. Unix has ulimits, those kind of stuff. Those are obviously platform dependent.
Yeah, some of those things don't carry over quite well to the Windows world, right?
Yeah.
So yeah, we haven't really talked about sort of features of Elvish. What does Elvish have over like the sort of the mainstays, like a bash, for example? What does it do? Like, what would wow me? I'd be like, wow, Elvish is very different, very powerful. What would stand out?
Right. So that kind of goes back to the origin story of why I decided to write a new shell. I kind of did it mostly out of frustration. So I had kind of two experiences with more traditional shells at that time. One was I was doing a little bit of system administration for some local Linux servers, and I got exposed to a 1,000-line bash script, and I was trying to maintain it, and I just found it impossible because it's like full of all those obscure things. Like you always have to put your variables in double quotes, right? Because otherwise the white spaces in the variables will do naughty things. And you can never figure out what's the correct way of comparing two strings. Like there's a test command, and bash has this left bracket command that's the same as test. And it also has a double left bracket command that's not the same as test, but instead is something else. So all those details were pretty much driving me insane. So I thought there must be a way to write more sensible shell scripts. But at that time, I didn't actually find a lot of good ways to write sensible shell scripts. So that's one experience. Another experience was I switched from bash to zesh, and I was trying to implement directory history. Because at that time, that was before things like Oh My Zesh came along. So there wasn't that many like out of the box Zesh plugins floating on the internet at that time. So you kind of have to do things kind of yourself. So I was trying to implement directory history, and I read through a lot of Zesh's man page, and because Zesh actually has some fancy UI features, like its tab completion is pretty fancy. So I thought it must have good kind of primitives for doing sensible UI stuff. But the entire UI system, I also got a little bit frustrated. I basically gave up because the API is it can do very powerful things, but it's not the easiest to use, to be honest. So kind of these two experiences made me think, one, we need a shell that actually feels like a real programming language. And second, we need a shell that actually has sensible UI features out of the box. So those are kind of the two main themes of Elvish. Is one has real programming features. So for as a starter, like Elvish has lists and maps, and they can be nested. Whereas in more traditional shells, it probably, if you go back to the very origin, like Born SH, the only thing it has is strings, right? And you can split strings on spaces. So you can put spaces in your strings that you can pretend you have lists, but not really. And some later shells have actual lists or even maps. but they don't nest. Like you can have a list of strings, you can have a map from strings to strings, but you can't have like a list of lists or maps of maps. That's just not a thing in more traditional shells. But Elvish has all of those things. It's like a program language. Like anything you can represent in JSON, you can represent in Elvish. And Elvish also has lambdas, so it has functional programming. It is a very functional kind of programming. I'm saying programming twice. It's a very functional programming language. So a lot of the code in Elvish will look a bit like Lisp because it embraces kind of the FP paradigm.
Mm-hmm.
So that's one thing. Real programming features, but it also has like out of the box UI features. Like one thing, I will give two examples. One is that it has a built-in file manager. So if you just press Control N in Elvish, it gives you a view of your current directory, your parent directory, and a preview of the file you have selected. So if anybody has used Ranger, kind of the UI is very much a copycat of that.
Mm-hmm.
And another thing is, so in Bash or Zesh, you have this, you can press Control R to search your command history, right? But it only gives you one match at a time. In Elvish, I kind of stole the same key binding, but if you press Control R, it doesn't let you search one command at a time. Instead, it just gives you a list of all your historical commands, and you can filter that command, and you can see all the commands that match your current filter. So you can do things like that.
So you ship with some built-in commands, but you also rely on external commands. I mean, like pretty much like you would in any other shell, and basically running Git or any sort of external tooling. So the other built-in commands sort of geared towards sort of the programming tasks that you normally need to do, kind of thing.
Right. So that's a very good question. So I would say mostly yes, but there's also a bit more consideration about what kind of commands people tend to need in their shell, right? So it's very much built like a programming language. So one interesting example that I can think of is, for instance, like in Unix, you have a mkdir command to make a directory. And that's very much geared towards interactive use. For instance, you can make multiple directories with it. But in Elvish actually also has a built-in mkdir directory, although it lives in a separate namespace. It's called os:\mkdir. But that one actually only takes a single argument because it actually functions very much like Go's mkdir function in the OS package. And if you want to make multiple directories, you can just write a loop. So it's definitely kind of more on the programming language side of things.
Right. So you wouldn't, so you're not trying to maintain sort of compatibility with sort of existing sort of tools out there, right? Like normally you do your mkdir, with a dash p flag, and then you can do the whole, the multiple slashes, and it creates, that tree. But you're like, okay, well, I don't need to do that. If I need to create multiple directories, I'm going to use some for loops.
Right. So it's slightly more nuanced than that. So as a starter, Elvish doesn't prevent you from using any of the existing programs. So when I'm using Elvish, like I use macOS most of the time these days, I can still use the system's mkdir, right? And I do use it a lot of times. I still use it as my kind of the default way of making a directory. I would still use mkdir. But Elvish's built-in mkdir, it also lives in a separate namespace, as I mentioned. Like it's called os:\mkdir instead of just an mkdir. It is useful when, for instance, you are trying to write a portable script that can run like on both Unix environments, on Windows. Oh, and did I mention Elvish supports Windows? I did not, but
Yes.
Elvish supports Windows. So a lot of time, those built-in commands, they really shine when you are trying to write those kind of portable scripts. But if your concern is really just like writing a script you use on your system, then you can just use anything that you want. You're not restricted in any way to use Elvish's built-in commands.
So I'm looking through the reference for the modules, right? Seem beyond the built-in stuff. You know, you have modules for documentation, for editing. There's a package manager, command line flag parsing. There's math. There's quite a few things here. So these things,
Yep.
looking at them, most are really sort of geared towards. I mean, there's a lot of them that are geared towards sort of a so directory and file handling and whatnot. But you know, some like string manipulation, for example, are things that you would sort of need sort of in your day to day. If you were like a sysadmin and you needed to sort of write, you know, some scripts here and there, those would come in handy, I would imagine. So there's a mixture of things here related to sort of system, sort of a file and directory manipulation, but also there's some runtime stuff and whatnot. So it sounds like you built a tool to deal with that 1,000-line bash file.
Yeah,
so did you ever go back and modify that thing, or had you moved on? Is this a tool you wish you had back then?
Yeah, I didn't go back to that 1,000-line bash script because somebody else took over the maintenance of that script. But I did rewrite. So Elvish has scripts, like the project repo has a bunch of scripts inside it. And over the years, I have rewritten all the bash script in Elvish, and it's always an improvement. Yeah, like the string manipulation thing you were just mentioning. So, like Bash does have string manipulation functionalities, but they usually have pretty obscure syntax. Like Bash, there's a built-in way in Bash to remove a prefix from a string, and the way you do it is, say, if your string is $s, what you do is dollar and then brace s, and then I think it's hash, and then hash prefix, and then closing brace. So it uses like this kind of very symbolic syntax. It makes extensive use of punctuations, which I guess if you do this on a daily basis, you will remember and you will like how concise it is. But if you only do this like once per week, you probably are not going to remember it. And you will keep doubting yourself, like, is this the right punctuation? But in Elvish, because it's designed like a programming language, you just go to the str module and there's a function called str trim left. Or there's also a module called, there's str trim left and there's str trim right. And there's str trim left and str trim prefix. So those are the things you would use because like it's slightly longer, right? Than like just writing a hash sign, but it is much more readable. And if you're a Go programmer, these are implemented using the same functions inside Go's strings.
The strings package. Right.
Yeah.
Right.
And they behave identically because it's literally just implemented using the function from Go standard library.
Is there a particular feature that you implemented in Elvish where you were like, okay, this is why I picked Go. This is sort of the perfect use case.
Yeah. So there are actually two. One is where I was just going to, right? Is the standard library. So Go has a great standard library. It's very high quality. It's very well documented, and it's a lot of batteries, right? And it's a lot of good batteries. So like you were just going through the reference manuals of Elvish. If you look at that, like half of it is basically just Go standard library, just with like an Elvish binding. So the str library is just Go's strings library. The RE library for regular expression is just Go's regex library. I made the names slightly shorter because in Elvish, like module names and variable names, actually they don't live in the same namespace. So I can't afford to make it kind of a slightly shorter. And there's the path library is just Go's OS/path. The OS library is basically Go's OS library. Like math is basically Go math. So much of Elvish's standard library comes from, not like some of them literally just come for free because there's a very straightforward way to change that, like to adapt that Go API to an Elvish API. I use reflection for that. And some of them requires a little bit of wrapping, but never too much. So standard library is one very like large part of the reason of why, if I do it today, I would still do it in Go, because I think most other languages, they don't really have like as extensive as a standard library as Go. Like if somebody asks, like, can I have a HTTP library like as part of Elvish standard library? And I can probably just use Go's HTTP library for that, right?
Right. Yeah, just create the Elvish bindings and off you go.
yeah, exactly. Although because the HTTP library deals with a lot of functions, function bindings are like slightly harder because Go, like the way you do functional programming in Go and Elvish are slightly different. Another thing, aside from the standard libraries, a very interesting part of the runtime that I didn't really think about it when I first started using Go, but Go is a garbage collected language. Elvish is also a garbage collected language. So a happy consequence of this coincidence is that I don't have to implement my own garbage collector, because Elvish values are just Go values. So if an Elvish value becomes garbage, it also becomes garbage kind of in the Go runtime. So it will be collected by the Go garbage collector. But if you write like a new programming language in Rust and it's a garbage collecting language, you do have to spend time writing your own garbage collector, or maybe use one of the existing garbage collectors. But in any case, you will need your own garbage collector. But if you're writing in Go, you don't need your own garbage collector.
I keep thinking like these days when folks are making programming language decisions, slight tangent here, but the perhaps it's just me, but I think the decision to use a programming language or not, the decision making process, why you'd pick a language over another, it felt like it used to be more technical, like more stringent, like more like you had specific things you would be looking for, right? Whether you wanted a garbage collected, like an interpreted language, or compiled one, or a garbage collected one, or no garbage collection, right? Like these decisions these days seems like whatever's cool, grabs attention. But I think for our listeners, I'm sure many are thinking, okay, the process of selecting a language should be a bit more sort of critical, right? You should take a more critical approach, or critical eye, right? This goes back to the whole pick the right tool for the job kind of thing, right? Most, at least from what I've seen, most programmers with a any sort of medium to long term career will pick up a few languages and put that in their tool belt and use the appropriate language for the given situation. So when you mentioned that, okay, I'm writing Elvish, it has GC, and I can just piggyback on the languages, the underlying language GC. Like to me, that one, I'm like, okay, that's a good reason, right, to pick a language, right? And when you're deciding what tool you're going to be using to build your own product.
Yeah, definitely. Although it is something I wasn't actually thinking about when I first picked Go.
It's just a happy accident.
Yeah, but later when I was reading a lot of articles about implementing garbage collector for their new language, I suddenly realized, I never had to do that. And I realized I never had to do that because I picked a garbage collector language as my implementation language.
Nice.
It was the right choice, but it was unconsciously made at that time. But when I look back, it's a very sensible choice.
Was there any feature that Go made particularly difficult?
Right. So not really, I would say. So I don't think of I can't really point to one feature in Elvish and say it's all Go's fault that I have to write 3 times more code compared to implementing Rust. There is not a single feature that's like that. And I think it's because Go is actually a very good language for when you think about applications. It's a very good language. It's very geared towards implementing applications. And I mean, Elvish is obviously an application. You can consume it as a library, but I don't think of it as a library that much. I don't worry about it as a library that much. However, there are things that I think does make it kind of a slightly more painful, more ugly in Go, is that, again, goes back to, I don't think Go is actually a very good language for implementing a library, because I would mention kind of 2 things. One is that Go doesn't have true enums, and it doesn't have true tagged unions. And if you're thinking about implementing an application, you don't really worry about that too much. But if you're thinking about implementing a library, a lot of time the API can be much more cleanly modeled if you have true enums or true tagged unions. And for instance, like the Elvish's parser, like there are maybe 20 different types of nodes in the syntax tree. And it would be very handy if I actually have like a Rust style enum that says like a node is one of those 20 different types of nodes. That's actually can be quite handy. It makes some code a bit cleaner. So even though I don't think of Elvish itself is not a library, it's an application, but it's kind of made up of kind of it's built as small modules, which themselves are kind of libraries, right? And internally, it does create a little bit of kind of internal friction, but it doesn't really show up on the overall application level. Another example is like Go doesn't have keyword argument, default arguments. And the way people work around that is maybe like have a struct, and whenever you want like 2 keyword arguments, you just make them fields of the struct. It is fine if you're building a library that's consumed by a lot of people. But if you're just building like kind of an internal library, an internal API, it does feel like this is a bit too much boilerplate. So it doesn't make for the Go doesn't make for the cleanest API is kind of my take. Mm-hmm. So a lot of time I just keep staring at a piece of code and think, I wish this looks a little bit cleaner. I wish this looks a little bit more beautiful. But you have to accept kind of the limit of the language.
So what's next for Elvish? Is that something you're still adding sort of features to, or are you just fixing bugs at this point? What's the state of the project?
Yeah, so I think kind of in the short term, so in the past few months, I have been working on a new TUI framework in Elvish. So if you think about, goes back to our very earlier discussion of what a shell really is, right? Like if you think about the browsers, there are a lot of those frameworks, React, Angular, Vue, that you can use to build kind of very modern, very clean web applications. I think there are some that lets you build good, clean terminal applications, but I think we could probably use some more, especially if it is a TUI framework that you can just access directly from your shell. So if it's something that you actually use every day, and you can use the TUI framework to kind of extend Elvish itself to give it a little bit more interactivity, or you can just use it to implement new TUI applications. Like you can probably implement Tetris in the new TUI framework. So that is something that has been kind of in the works for multiple months now, but it's I'm hoping to kind of merge it into the main branch of Elvish soon. So when that happens, Elvish will become like the UI. Like I said before, like the two main things about Elvish is that it's a real programming language and has good UI features. And I think if you have a TUI framework in Elvish, this is where those two things actually kind of come together and become kind of a whole. It becomes a UI thing that you can very easily program. I think that would be pretty cool. So that's the immediate next thing. But if you think about kind of the long-term future, again, this goes back to what we discussed before, is a lot of people confuse shells with terminals. And I think there's a good insight in that like it should really be like just one runtime where you can manage your programs, right? And there are a lot of things that you can't easily do because these are two separate programs. Like if I have all the, like shell have command histories. You can look at which commands you have run, but the command histories don't tell you what the outputs of the commands are. It's because the shell actually does not have control over those commands after they have been launched by the shell. The terminal has control of those commands. So you can probably do more cool things if like your shell and the terminal is actually kind of more tightly integrated, or even just like one application. But that's kind of very vague, very futuristic, I guess.
Okay. I'm kind of pleased you didn't, mention, I'm going to throw an LLM in there and have that generate commands for you and things. That's the new hotness these days. Everybody needs to put Gen AI somewhere in whatever they're building. Yeah,
but I think with the new TUI framework, maybe somebody will build that into Elvish kind of as a plugin. I'm sure of that. And to be honest, like LLMs, they are used, like I've had some success in asking them like crafting ffmpeg commands.
Mm-hmm.
Because ffmpeg just has so many different options.
Right,
so
right.
it's quite useful. But sometimes it does give you like very subtly wrong shell scripts. So I would probably trust LLMs for like one-off commands, but I really wouldn't trust it for writing scripts.
Exactly, especially with anything with any command where it has destructive effects, like directing manipulation, deleting files, or anything like that. I would never ask an LLM to generate that for me. That's just the risk here is just too high.
Yeah.
Okay, friends, I'm here with a new friend of ours over at Timescale, Avthar Suwathan. So Avthar, help me understand, what exactly is Timescale?
So Timescale is a Postgres company. We build tools in the cloud and in the open source ecosystem that allow developers to do more with Postgres. So using it for things like time series, analytics, and more recently, AI applications like RAG and search and agents.
Okay, if our listeners were trying to get started with Postgres, Timescale, AI application development, what would you tell them? What's a good roadmap?
If you're a developer out there, you're either getting tasked with building an AI application, or you're interested and you're seeing all the innovation going on in the space and want to get involved yourself. And the good news is that any developer today can become an AI engineer using tools that they already know and love. And so the work that we've been doing at Timescale with the PG AI project is allowing developers to build AI applications with the tools and with the database that they already know, and that being Postgres. What this means is that you can actually level up your career, you can build new interesting projects, you can add more skills without learning a whole new set of technologies. And the best part is it's all open source. Both PG AI and PG Vector Scale are open source. You can go and spin it up on your local machine via Docker, follow one of the tutorials on the Timescale blog, build these cutting edge applications like RAG and such without having to learn 10 different new technologies, and just using Postgres and the SQL query language that you probably already know and are familiar with. So yeah, that's it. Get started today. It's a PG AI project, and just go to any of the Timescale GitHub repos, either the PG AI one or the PG Vector Scale one, and follow one of the tutorials to get started with becoming an AI engineer just using Postgres.
Okay, just use Postgres, and just use Postgres to get started with AI development, build RAG, search, AI agents, and it's all open source. Go to timescale.com/AI, play with PG AI, play with PG Vector Scale, all locally on your desktop. It's open source. Once again, timescale.com/AI.
I actually think you should probably leave.
Okay. So, I hope you brought some unpopular opinions. You got one for me?
Yeah, of course. So my unpopular opinion is that when it comes to testing, 100% code coverage should be the minimum, not the end goal.
What? You want 100% test coverage?
Yeah.
Okay. Like, explain that. I'm pretty sure that's not going to be popular with a few people. Explain yourself, sir.
Right. So let me make this probably slightly less radical. Well, not by changing what I said, but by saying that, like, because we all of us want 100% code coverage. But if you look at the test coverage of your application, of your library, it's probably not 100%. But we all think that all of the code must have been run at least once for us to know that it actually functions, right? If there are 10 lines of code in your code base that just has never been run before, like, why do you even have it? Like, why do you keep it? And your answer to that may be, I actually did manual testing, and that relies on these 10 lines of code. It's just not captured by my automatic tests. And I would say that in spirit, that counts as 100% code coverage. So it is actually something we all strive for. We just can't achieve 100% code coverage in automatic tests, in unit tests. But kind of deep in our heart, we all know that if you have written 10 lines of code you must have run it once to make sure that it's actually useful. And the reason I say is the bare minimum is that running the code, making sure the code has been run at least once is really just the start, right? Because if you have written a program that just prints out like A and B, and it's supposed to print out A and B, but actually prints out C, and you have run it once, but you never check what the output is. That code, like, technically has 100% code coverage, but you're still not sure that it is correct. And to make sure that it is correct, you have actually put the correct checks in place. So having run the code once is the start. You also have to make sure that you have actually checked the effect of that code. So this is my take on code coverage. And I think the reason people shy away from 100% test coverage is, first, we are not really adequately capturing all the activities we have done into like code coverage, right? Like if you write a program and you do manual testing, the code that you have triggered during your manual testing is not counted as part of the code coverage. And worse still, sometimes if you do integration testing, the tooling part also prevents you from like counting that as part of a code coverage. Like most of the metrics only actually count unit tests. But I think Go actually, a few versions back, they actually implemented support for counting end-to-end test coverage. So you can now generate code coverage for end-to-end tests, which I think will make a lot of projects' code coverage go up a lot. Because when you actually run the binary as a whole instead of like running a single function in a unit test, that usually exercises a lot of code paths. So I think we should all embrace that. And another reason is that a lot of libraries are just like outright untestable, right? For instance, if a function just like calls os.exit, like you're not going to test that in your unit test, because that would just exit the entire like a unit test program. But why not? You should be able to test those things. And if your program sends something over the network, that can be a little bit hard to mock. And what people usually do is just like extract the computation part of your program and only test those parts, and you don't test the part where it actually interacts with the real world. But I think you should. And I'm not blaming everybody for not doing that. I'm saying that the ecosystem doesn't give us enough support to like do those tests easily. But I think that is something that should be changed.
Okay, well, I mean, not an extremely radical take. You know, it's I think, you know, I can parse some sensibility in there. You know, it's all right. Yeah, I have perhaps not an unpopular opinion, but like I recently, as we're recording this, I think a few days ago there was a keynote that I watched. There was a GitHub Universe conference going on, and there was a keynote. In the keynote, they were talking about sort of the Copilot and, you know, its ability to like the whole Spark system, whatever, its ability to generate sort of apps from scratch and all that stuff. And that's usually one of the selling, you know, points, the marketed stuff that says, hey, you can build an app from scratch, blah, blah, blah. And it's always like the pitch is always to generate these new sort of one-off, usually very small, very sort of, you know, low feature kind of thing, kind of applications, just to show that, hey, look at this thing. You don't even need a program anymore. But these things are usually like very simplistic, you know, sort of applications. Not to say that some of them aren't sophisticated, but when you're generating things from scratch, like, you know, a greenfield, right? You have the benefit of basically writing everything from scratch. But for existing systems, for existing large systems that have been around for years, you know, decades even, right? Those are the things that I need help with. Those are the things that, you know, when I'm tasked with maintaining a system that I've, you know, say I was hired by a company and they've been running the software that runs their business for well over a decade. And here I am tasked to make a change or add a feature or whatever. And those are the things that I need help with, right? And I'm not generating, you know, like CRUD apps or to-do apps, you know, with an LLM from scratch. I'm trying to work into an existing code base. So one of the things that they showed was there was some sort of I think it's just available for Java, but there was something that could help you upgrade or something your application. Maybe like you have an old school, Java app. Maybe you need to upgrade, the which virtual machine version it uses or whatever the case may be. But it's going through all the different files in the project and basically changing the syntax. Maybe you use old school syntax, that new syntax to represent something. Maybe you want to use lambdas or whatever it is, right? It's going through and sort of allowing you to change all these different files, basically upgrading an existing application, right? But I think even that doesn't go far enough. And I think there's always going to be a need for a human to provide some additional context, right? Some backstory for an LLM that wants to change code, because so much technical that I've seen in my time, a lot of people who no longer work at an organization, they walk out the door with institutional knowledge in their heads. It's not documented. You see a piece of code and you're probably in a situation, you change something and you think you are doing the right thing. And then all of a sudden you broke something else somewhere else, not thinking that, oh, wow, I didn't know why this code was there. It just seemed like a wrong thing. So I just fixed it, right? Quote unquote. And then you end up breaking something else you didn't know was relying on the code to work a particular way, right? So that this technical debt sort of stacks up over time. And it's not like, people are keeping track of, the reasons why they can't change or shouldn't change something, right? So when you throw an LLM at these kinds of situations, not to say that one day we won't be able to sort of have models powerful enough to sort of fix those things, but these are the kind of, like when they're doing those marketing presentations and getting everybody excited about, large language models and Gen AI, those are the kind of demos I want to see. Take an existing app with a lot of assumptions baked in, like refactor that, because that's my job. I'm not generating, 3D chess program, for work. That's not what I'm doing. That's not how I earn my living. I work on old, like legacy systems with a lot of assumptions, a lot of decisions that were made prior to me getting in front of this code base. Like, help me deal with that mess, right? And not the trivial stuff. So perhaps not an unpopular opinion, but more like a request. Well, I don't even know what it is. It's more of a perhaps letting everybody know that, yes, the demos look cool, but we're still some ways away from truly being able to leverage LLMs to do the things that we really, really care about, right? Unless you're building something trivial in greenfield, which is not most of us. So,
unironically, I think this is where 100% test coverage will help. Like if your code has really good test coverage, you may be more confident in letting a language model try to make changes to it, because you have some confidence that some of the old behavior is probably kept.
Yeah. Maybe the tests come with the baked-in sort of assumptions that were made for the code that they're testing, right? Yeah.
And I think language models may also be useful for kind of suggesting you, helping you achieve higher test coverage, suggesting like they're really good at generating things, right? So you can make them generate tests as well.
Mm-hmm. That is true. Yeah, that is something I'm increasingly relying on models to do. It's which is kind of interesting. I'm wondering how TDD purists are dealing with this, right? Because if I can just focus on making the code work, and then I can then throw an LLM at it and say, hey, write tests for this, then I can focus on getting the proof of concept or the working code. I can focus on getting that done, because a lot of people I've come across, they love writing tests because it helps them through the thinking process, right? But some of us, we like to write the code first, test later. So perhaps those of us who like to, I guess there's you could also have an LLM generate your test first, but you'd have to be very descriptive at your, in your prompt to tell it, what to generate for you before you go write the code that passes the test. But yeah, it's an interesting time to be a developer. I'll tell you that.
Yeah, definitely.
All right. Well, it's been a pleasure having you. It's been great to actually learn about Elvish, what it does, and how Go has helped along in that journey. Yeah, I wish the project continued success. Thanks for coming on.
Well, I'm glad to be here. Thank you.
Thank you for listening to Go Time. We appreciate you spending time with us each week. If you haven't yet, check out Changelog News. It's the industry's only weekly newsletter that's also a podcast. One reader calls it so good, he considers it a competitive advantage. Read and listen to the latest issue at changelog.com/news. Thanks once again to our partners at Fly.io, to our beat freak, the GOAT, Breakmaster Cylinder, and to our longtime sponsors at Sentry. We love Sentry. You might too. Use code changelog. Save $100 on the team plan. Too easy. That's all for now, but we'll talk to you again next time on Go Time. Mm.